Minecraft.
Hello everybody and welcome back to the show. Today's episode is about nuclear power. Using the ReactorCraft mod from Reka, we're going to build ourselves nuclear power, a nuclear reactor, nuclear power plant. So let's go ahead and get started with that. I'll give you a little bit of an introduction to what we're going to build, and then I will build it and I will show it to you, and hopefully it will work properly. It's kind of a test of myself to see if I can actually do this right or not. So let's go ahead and get started. Okay, so before we get started working with this mod, one thing I thought I'll mention is, much like with RotaryCraft, Reka is doing his best to emulate real world physics and structures, and the ReactorCraft mod is not any different in that. It's based upon real world type items. What we're going to be building is called a Pebble Bed reactor. Now, if you live outside the United States, you may know or have heard of a Pebble Bed reactor. And if you live inside the United States, you may have never heard of a Pebble Bed reactor. And that is primarily because the United States, in all of its infinite wisdom, just decides to blank out any mention that includes the word nuclear in it. So despite the fact that Pebble Bed reactor technology is is showing itself to be safe and a good source of power, the country that I live in is still burning oil and coal to generate power. So maybe someday they will come to their senses and try out new things and not be afraid of the word nuclear. But until then, well, we just have to wait and see. But anyway, we're going to build a Pebble Bed reactor, and the Pebble Bed reactor is called that because of these things which kind of look like pebbles. Now in the real world, these triso fuel pellets are about the size of a softball, I think, if I remember my Wikipedia correctly. Triso, T-R-I-S-O, stands for tristructural isotropic fuel. I don't know, it sounds fancy. I call it triso fuel pellets. These are easy to make. Some uranium dust surrounded by graphite. Uranium dust is made by grinding up some pitch blende, and the graphite is made by smelting some coal dust, which is made by grinding up some coal. So I have been doing that over here with my extractor. I dumped some coal in. I'm doing iron right now, but dump some coal ore in, get coal flakes, cook that into coal, or smelt that into coal, and then grind that into coal dust and smelt the coal dust into graphite. Now I also take pitch blende, put that through, get pitch blende flakes, smelt that into pitch blende ingots, and grind that up to get uranium. And that is how we end up with these triso fuel pellets, some uranium surrounded by graphite. And in the real world, that's what these fuel pellets are. They are the fissionable material, which is usually uranium, surrounded by layers of coal or carbon around it, which helps to maintain the uranium inside of it and allows it to fission and not leak out up to like temperatures of like 1600 degrees or something crazy like that. This design is one of the things that makes this type of reactor safe. This uranium, there's no waste that's generated. There's no uranium leakage to get out of it because it's safely contained in this sphere. So anyway, these triso fuel pellets, they get put into something called the Pebble Bed reactor core, and when they're in there, that's when they will start to fission and generate heat. So that heat then gets bled off into a carbon dioxide heat exchanger, and what that does is it will take cold carbon dioxide, and the heat coming off of the reactor cores will heat up that cold carbon dioxide and of course turn it into hot carbon dioxide. We take that hot carbon dioxide and we feed that over into a heat exchanger. The heat exchanger takes the hot carbon dioxide, turns it back into cold carbon dioxide, and the heat from that hot carbon dioxide is bled off into steam boilers, which will have water in them. So the steam boilers will boil that water, which will create steam. Those get released through a steam grate, and those ultimately then get released into these turbines, which will spin and that spinning is the rotational power that we get out of doing this. Now, I know it sounds, maybe it doesn't sound complicated. I've read this several times, so it makes a lot of sense to me, but it's fairly basic. Fuel inside the core causes heat. That heats up carbon dioxide. The heat from the carbon dioxide will then heat up water, which will boil and turn into steam. Now, if you're like me, you might say, okay, why don't I just take the hot carbon dioxide and use it to power the turbines? I don't really have a good answer to that question, to be honest with you. I don't completely understand this, but what I think is that water, which is what is in the steam boiler, water can maybe carry or be affected by the nuclear uranium that's in the pebbles, whereas the carbon dioxide is what they call an inert gas, and it cannot carry. So I believe by separating these, if there was to be a leak, instead of that uranium getting into a water supply, the uranium would not even be able to mix with the carbon dioxide since it's inert. And that just adds to the safety of the reactor in general. This reactor I'm going to use, you'll see it when I hopefully get it up and running and it's running properly. The nice thing about that is, as I said, there's no risk of a nuclear meltdown. There's no nuclear waste to have to deal with. And in addition, there's nothing that can really break. These don't get hot enough to break. These don't get hot enough to break. None of this gets hot enough to have any problems. Sometimes the steam boiler can get too hot, in which case it will just break and not work. It will, in the game terms, it will just turn into scrap metal. But nothing in this entire design will cause any kind of an explosion in the event that I haven't built it properly or put it together properly. And that's another nice thing, is that I can't really lose a lot of the materials and time and stuff that I've put into it, which is something that's nice. So anyway, I am going to now go off and I'm going to build this. It takes a little while. It's got to be built in a certain way. I'll come back after I have it built so you can see it, and then we'll get it up and running and hopefully generate nuclear power. Well, I am hoping that I have constructed this properly. It's always a question. So this will we're going to see what will happen here. So I'm going to go over this again. I know it can be a little bit complex. First of all, this is concrete. This is added by ReactorCraft. It's just more of a decorative block than anything else. Sand, clay, gravel, water, and you get concrete. You don't have to use concrete to surround your reactors with. I think you can pretty much use any block. But I decided to use the concrete because, you know, keep with the theme and keep with the flavor of it. Real life reactors are surrounded by concrete. The main reason why you want to surround your components with concrete is to keep in the heat. So these Pebble Bed reactors, as I said, once I put in the Triso pellets, they'll start to heat up. And then they dissipate their heat out to the sides. In which case, in this example, this carbon dioxide heat exchanger is to the side, so that's how the carbon dioxide heat exchanger will heat up, because it's absorbing the heat from the Pebble Bed reactor cores on either side of it. However, if you have airspace next to it, it will also just dissipate heat off into the air. But if you have a block next to it, then it won't. And then I use these half slabs so I can see and have access to these components. I believe that the half slabs act as if they are actual blocks as far as ReactorCraft is concerned. So even though I can see and have access, the components will think that there's a block here and thus keep their heat in better. Now, this may not be the most efficient design as far as one of these Pebble Bed reactors go, but I use it because it gives me the access. Now I need to be able to, you can see if I open the interface here, I need to be able to put these Triso pellets in here. So, and I did need 4 of them, so one way to do it is to only have one carbon dioxide heat exchanger. If you imagine it like that, if that's the carbon dioxide heat exchanger, and then to put the 4 Pebble Bed reactor cores around it like this. And so then as these heat up, they will heat up this carbon dioxide heat exchanger in the center. I didn't want to do it that way, because if I do it this way, then I have access to be able to see everything. You don't actually have the ability to access this carbon dioxide heat exchanger. There's nothing that you can click on, or you can right click on it, but nothing happens. But I like to be able to see it. As you can see in the tooltip from WAILA at the top, shows me what temperature it's at. And I don't really need to know that, but maybe just my own, the way I am, I want to be able to see it. So that's why I'm using this particular method. And it's hard to see because I got all the concrete around it, but I have these gas ducts. These are also from ReactorCraft. They're made by surrounding glass with hardened clay, and they are used for transporting the carbon dioxide. And here is the heat exchanger that I was talking about earlier. So the hot carbon dioxide will go out the top of the carbon dioxide heat exchanger through this gas duct and then come down into the heat exchanger. And the cold carbon dioxide comes out the side and then goes down and then back up into the carbon dioxide heat exchanger. So when this heat exchanger heats up, it will heat up this steam boiler, which you can see is full of water. And when the steam boiler heats up, it will send steam out through these steam lines, which just goes down here and down. And there's the steam grate. The steam will come up out of the steam grate and start spinning this turbine. And I've put a dynamometer on the end of this so we can see how much power we are generating. Now I do have 2 AC engines operating here. I've got one AC engine operating a pump, which is over a 4x4 infinite pool of water, and all it's doing is keeping this reservoir, 4 reservoirs, filled up. These reservoirs, then send their water. Shouldn't have blocked all this up probably, but it sends its water out of that down and into the over here into this steam boiler. And remember, this steam boiler is going to need a constant steady supply of water. If it goes dry, then it does have a chance of breaking. Again, I won't get any kind of explosion that, you know, like a nuclear explosion that would be deadly or anything like that. But I could lose the steam boiler, so I don't want to have that happen. The other AC engine, is there, and it runs in through a 2-to-1 gearbox, which comes up, and that's what provides power to this heat exchanger here. This heat exchanger does need a source of rotational energy power in order to work properly. None of the other components need that at all. So that is the setup for the reactor. I'm going to go ahead and block these up again real quick to keep the design. One thing that's important is that these turbines are extremely delicate. First of all, while they're spinning, I think if you walk into them, you will probably die, and you will break the turbine blades. And you'll have to replace them, and they were expensive to make. They're probably the most expensive component of this entire build, so you do not want to have to do that. Similarly, you don't want mobs getting into them, and one thing that I've noticed that has to be worried about if you're in a cave or underground or anything like that is bats. Bats can spawn, and you do not want to get a bat in there. The bat will die, but it will break your turbine blade, and that's not good. Now this turbine blade is actually 5 turbines, 1, 2, 3, 4, and 5. And that's why they are so, oops, I can't spell turbine. That's one reason I still cannot spell turbine. And that's one of the reasons why they are so expensive. Here's the turbine. As you can see, each one requires 8 of these propeller blades, and the 8 propeller blades consist of a steel ingot, a base panel, and a shaft unit. Shaft units and base panels, of course, are also made from steel ingots. So this is roughly 1 2/3 steel ingots per propeller blade. So if you just rounded that off to 2, you're talking about 16 steel ingots per turbine. And of course there's 5 of them, so you're looking at 80, is that right? 80 steel ingots just for the propeller blades. Then you have the compound turbine parts, which require these turbine pieces, which are even more propeller blades, times 2 times 5. I'm not going to do all the math on that, but needless to say, it requires a lot, and the last thing you want is to have any of these get damaged. Now, the reason you put 5, you don't have to use 5. You can use 1, 2, 3, 4, or 5. But what happens is the efficiency, if you use 1, is like 5. And if you use 5, it's 100%. And it's scaled in there. So it's not even a factor of being like 20, 40, 60, 80, 100. It's 5 and then 100. And in this, like using 4 is not 80, it's less than 80. So basically there's no reason to not use 5. I mean, other than trying to save yourself materials, but if you get to the point where you're going to build this nuclear reactor, you might as well build all 5. Save up the materials and get all 5. That's what took so much time between last episode and this one, was getting all the iron, turning it into steel. And yeah, so that's why it is. So anyway, this is all built and hooked up. There's one thing that we're missing, and that's the carbon dioxide gas. If you see the gas duct, doesn't really say that there's anything in it, and that's because there's not. It is empty. Gas duct is empty. So we need to put carbon dioxide gas into the gas duct. And that is actually fairly simple. All you need is a furnace, and we'll just put one down, say here. And then you make something called a gas collector. And you put that on top of the furnace, so it looks like it has a hat. I think it looks like it has a hat. I don't know why, but I think it looks like it has a hat. Anyway, take some more of these gas ducts and put them on top and feed it over into the cold, oh, no, I don't want it there, into where you have the cold carbon dioxide line, just right there. Now, the carbon dioxide gas will be created whenever you burn off any wood or coal, or I think even charcoal. So all you have to do is burn some coal. Of course, in order to burn some coal, you have to be smelting something. So all you got to do is put some coal in your furnace and then put something else in the furnace. It doesn't even matter what it is. I'm just going to go ahead and drop some cobblestone in there. It'll start working, and you can already, you can kind of see there is some gas in there. If you look at the hot carbon dioxide line, that's still empty. And in fact, if I get out my angular transducer again, where are you? There you are. And use it, you can see gas duct contains 437 carbon dioxide gas. And if we go over here and look at our carbon dioxide heat exchangers, you can see that the tank is filling up with carbon dioxide gas. Basically, the carbon dioxide gas is it's a closed system. It doesn't bleed off, or you don't lose any of it. So once you have carbon dioxide gas in the system, you don't need to constantly be burning coal or wood or whatever in the furnace to supply it with more carbon dioxide gas. You'll always have some in there. So it's just a matter of getting some in there to start off with. And, once you have enough in there, you should be, fairly ready to go. So the next step, of course, is to actually put the Triso pellets into the Pebble Bed reactor. Each one of these Pebble Bed reactor cores will hold 47 Triso fuel pellets. So you can just shift click them in there like so, and like that. These will feed down into each other. So when, that gets a little bit complicated. I'll explain that another time perhaps. And essentially, if you look here, you might see this bottom one is what will begin fissioning first. When it gets used up, it gets sent to the top, and then the next one falls down into place. That's the whole concept of it being a bed, where it's falling into bed. It looks kind of like a funnel, or like the hoppers do. And there you go. See, that one's 8% depleted now. When you have them stacked like this, the empty ones will move to the top, and these fresh ones will fall to the bottom. But meanwhile, these ones all 4 of these are actually creating heat. So you can see the Pebble Bed reactor core is at 700, 700, 700, and you can see the heat's changing. And if I go look at the heat exchanger, you can see that it's rising as well. And when it gets to 800 degrees, that's when it will start turning the cold carbon dioxide gas into a hot carbon dioxide gas, and it just did that just now. And it is now slowly turning cold carbon dioxide into hot carbon dioxide. So that carbon dioxide we can now see is flowing in the gas duct over here to the heat exchanger. And so the heat exchanger, as I said, it gets the hot carbon dioxide gas, it turns it into cold carbon dioxide gas. And as it gets warmed up, it transfers its heat over here to the steam boiler. And you may be able to you can already hear the turbines are turning. And the steam boiler, every time it gets up to 100 degrees, it will boil off some water and turn it into steam. And then, as I said, that steam then feeds down into the steam grate, and you can see here the steam is rising up into the turbines, causing the turbines to turn. And if we go over here and look at our dynamometer, we're already up to 400 million watts of power. At maximum speed, this turbine will generate 950 million watts of power per second. That's a lot of power. Again, not to harp on it, but if you remember, these AC electric engines are outputting 131,000. This is 950 million. Remember, the block breaker required 2 million watts of power? That means that I could theoretically operate 475 block breakers at a time with the output from this small reactor. And remember, this is the the beginner reactor. This is the small reactor. ReactorCraft. Let's get out the handbook, and if we look in here, you'll see that here we have. Whoops, where is that? Right here. This is the Pebble Bed reactor core. It's also called a high temperature gas reactor. The Pebble Bed reactor core is a type of HTGR, but this is the Pebble Bed. This is the first one. Then you can also make regular fission reactors. You can make breeder reactors, and you can even make fusion reactors. And those machines will generate even more power than this one. But honestly, when this is fully powered at 950 million watts of power, quite frankly, I can't imagine that I would need a whole heck of a lot more power than that anyway. I'm sure I could come up with a way to use it, but it's going to take quite a bit. So you can see you do get some fluctuation in the torque from I guess that's just the way it is, the way turbines spin. But you can even see, so I'm generating 950 million watts of power, and if you look at the torque, it's 14,000 newton meters, and the speed is 65,000 radians per second. And those two numbers are pretty much sufficient to operate almost any of the machinery that exists in RotaryCraft. So, and again, these windows, they help me, to be able to come in here and look. You don't want your steam boiler to overheat and get too hot, but you can see it's not doing that. It'll overheat if it runs out of water. And as long as it has plenty of water, it can boil it off and turn it into steam. Similarly with the heat exchanger, as long as it's able to continually heat up the steam boiler next to it, it won't overheat or have any problems. You can come over here and look at our Pebble Bed reactor cores. They're operating at under 900 degrees roughly, and that's all they need because the heat exchanger only needs to get up to 800 degrees and it's not exceeding. So, watching the temperatures just to make sure they don't exceed too high of a number. And then the other thing just to make sure again is on the water. I've got 58,000. Looks like I am losing some water. Yeah, it looks like the water reservoir is dropping and not either staying steady or rising. So what I may have to end up doing is putting another engine somewhere and pumping in some more water to make sure that I don't ever run out of water. Because remember, the biggest problem I can have is running out of water for this steam boiler. Nothing else will cause problems. There will not be a nuclear fallout. There won't be any nuclear radiation. There won't be any nuclear waste from these Pebble Bed reactor cores. These Triso pellets will become depleted, but that's the worst that can happen with them. Nothing here will cause any problems. The only thing that can cause a problem is the steam boiler running out of water, and my reservoir here is definitely starting to go down. Okay, some quick alterations later, I've added myself another AC engine to another pump, and now you'll see my reservoir is going up. I'm at 46,000, and it's climbing. Obviously the level fluctuates up and down based upon when it's draining water and when it's gaining water, but it is mostly climbing. So now I do not have to worry about my steam boiler running out of water. I do need to keep an eye on these AC engines. They are, mostly powered by these shaft cores, and so if the shaft core runs out of power or Teslas, however, whatever that is, I don't know if that's power or what, but if it runs out of those, they will stop pumping water. So still need to keep an eye on things and make sure that there isn't any problems. But again, producing a max hits a peak of about 950 million watts of power, which is pretty darn cool. The next step, of course, is going to be taking this power and splitting it and piping it to all of the machinery that I need to run, which will be fun to do because it's going to be pretty extensive. Before I do that, I want to show you something real quick. Just it's kind of humorous to see, so I'll be right back. Okay, just to show you how much power we're dealing with here, I've moved my extractor and I'm piping the output from the reactor. 950 million watts of power, at least, well, at the max. You can see it fluctuates between about 900 and 950 million watts of power. I'm piping that directly into the extractor. Now remember in the past with the extractor with the 4 stages, I didn't generate enough power to be able to do all 4 stages at once. I could do stages 1 and 4, and then I had to have a switching system to do stages 2 and 3. Well, now you can see I'm obviously generating enough power to operate all 4 of the stages. Here's a neat thing about RotaryCraft machines, which I don't know if I've touched on before or not, but they have power requirements, speed requirements, or torque requirements. But in most cases, if you provide more power, usually in the form of speed, to a machine than it needs, than the minimum, then it will operate faster. So not only can I run the extractor through all 4 stages without having to have some type of switching mechanism, how quickly it will do so is just mind-boggling. I've got a stack of redstone ore here. Watch this. Yeah, it is that quick. When it gets over to this stage, watch this. It actually visually glitches showing a redstone ore solution here. There isn't one there. It cooked him up almost instantaneously. These 2 stages, now I'm not 100% familiar on this kind of thing, but my understanding is that a piece of RotaryCraft machinery that has a speed requirement doesn't benefit from being given more speed. And so these 2 stages require speed, so they're going to operate at the speed they operate. They're still operating pretty darn quickly. But the machinery, or in this case the stages that have torque requirements, they do benefit from having more speed, and you can see clearly they are doing so. I have spent the majority of the time up to this point just running ores through extractors. One of the reasons why it took so long to build those turbines was running iron ore through the extractor in order to get the iron flakes so I could smelt them into iron ingots and then put them into the blast furnace to make the steel. You spend a lot of time waiting for the extractor, so I'd go out mining, get a stack of iron, come back, dump it in the extractor, go out mining, and by the time I came back from that trip, the extractor would still be working on it. But now I am generating so much power that it is so much quicker running this extractor. Now, I'm not obviously going to use this entire nuclear reactor to power one extractor. I don't need to do that. That's a little overkill. But I just wanted to show you how different it was to have this running on an extractor, or having it run on a reactor. And to give you another idea of how powerful this nuclear reactor is. Remember my industrial coils? We talked about them in the last episode. They can store a maximum amount of 720 million joules of energy. This thing generates 900 minimum, and this is generating 900 million watts of power per second, which would be 900 million joules in 1 second, which exceeds the maximum amount that these industrial coils can handle. If I put this industrial coil, if it's empty and I put the industrial coil in line with this reactor, there's nothing that will be able to respond quickly enough to stop it from intaking power, and it will explode. It will get 900 million watts of power in 1 second, which it will exceed it and it will explode. I put it in line and it basically instantly explodes. So that's another kind of an idea of how much power this thing is generating. I seem to have a little bit of an issue with those are steam blocks that are up there that are created from the steam. The steam runs through the system and then is supposed to dissipate, but I'll fix that. That's not a huge problem. And our reservoir is steady at being full. We're generating power, and by now I should be able to have a few depleted, yeah, there you go, see, depleted Triso fuels. They just are depleted. It moves on to the next one in line. And oops, if I go to this one here, you can see same type of a thing. Next one's burning or fissioning or whatever. They do last quite a bit of time, but they're really not that hard to make. And especially now that I have so much power, I can operate an extractor really quickly. I can operate the grinders really quickly. And all I need to really do now is set up the power coming out of the nuclear reactor and split it amongst all of the equipment that I need, clean up the base a little bit, figure out how to set things up so that it's a little bit better organized maybe, and not so haphazard. But is there something? I thought there was something else I wanted to mention about the nuclear power, but maybe that's all that there is. So there you have it. Ladies and gentlemen, ReactorCraft, Pebble Bed Reactor, high temperature gas reactor, whatever you want to call it. It's pretty darn cool, and it's now generating so much power for me. Oh, I know what I wanted to mention. As I said, you can build fission reactors and also fusion reactors and breeder reactors to make fuel for your fission reactors, and those reactors will generate more power than this one will. But as I've demonstrated, 950 million watts of power, I'm not even sure how I'm going to use all of that power. It just seems like a lot of power to use. But if I get to a point where I decide I do need more power, one of the benefits of building this sort of side by side is I could theoretically add another line of Pebble Bed reactor cores, carbon dioxide heat exchangers, and Pebble Bed reactor cores. Feed that into another heat exchanger, which feeds into another steam boiler, and then into another steam turbine. I would have to, of course, get all the iron and steel and everything else I need to do that, but that shouldn't be too terrible. But I could do that and thus give myself another 950 million watts of power. So yeah, it's even though I could build one of the more powerful reactors, I'm not going to, because again, this one is safer, and no fear of it blowing up or causing radioactive waste or anything like that, and I'm getting lots and lots of power. So there you have it, ReactorCraft, power, so much 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 power. There you have it. Thank you so much for joining me. I hope you enjoyed it. If you have any questions, let me know. This is kind of sometimes a difficult mod to understand, but it's pretty darn cool when you can make something like this and actually see it, see these turbines spinning. They're spinning so fast that it creates that visual thing where I don't know, I can't remember what it's called. Anyway, I'm babbling again as I tend to do. Thank you for joining me. I hope you enjoyed it, and I'll catch you next time.